Okay, so can everyone hear me now? I think we have three, four participants. Okay, four. Okay, so how is everyone? Uh, we are. I'm good. I just actually I apologize that I didn't make an announcement early, but I have already uploaded the today's materials and everything on the Blackboard, so you can just download it. And if you have any questions, you can just let me know, and I will stop and explain it. I think for today's ANCOVA, it's not that hard. It's just everything, like sort of like everything we learned already. It's like a combination of everything we learned, so you don't have to worry too much. I think for today's ANCOVA will be a little bit different than what Dr. Kim said in lectured in the because I think he used the effect coding, and today we're going to just use the dummy coding, and some part will be the Helmer coding. So um, please pay attention to that, and let's get started. Okay, so for today's example, we're gonna use the math test, and our y value is the post test math scores, and our covariate is the pre-test math scores. And the purpose of doing ANCOVA analysis of covariance is to rule out the influence of covariate. So in this example, the C is used to find the position the subjects originally are. Okay, so in our data set, if you take a look at our data set, we have three groups, um, three treatment groups, which is the intervention with new curriculum, intervention with new technology, and a no intervention, which is the control. So we will denote those three groups as a group 1, 2, and 3. Okay, so just keep in mind that our reference group is going to be group 3, which is here the control group. Okay. Okay, so we are going to first we need to designate the treatment variables. So first, you can either use the dummy coding or effect coding. Those two coding scheme is introduced in the qualitative variables. You can check that in Lab 5. You can check the slides in Lab 5, and you will definitely find the useful information there. Okay, so in our data set, our coding scheme is dummy coding. But you can also use the effect coding. The only difference is that the effect coding here, the control is coded as -1 instead of 0. So the interpretation of the parameter estimates later on will be different, and the interpretation can be found in Lab 5. So definitely check on Lab 5 if you have any questions for that. Okay, so uh, we have three groups, right? So the only treatment variables we're gonna use is just gonna be 2, k minus 1. If we have 4 groups, we're gonna need 3 variables. If we have 5 groups, it's gonna be 4 variables, so on and so forth. Okay. So let's move on. So first, very importantly, we need to check the assumptions for ANCOVA. So pretty much the ANCOVA assumption includes all the assumptions for ANOVA, and it will have several more assumptions for ANCOVA itself. However, in our slides and also in our code, we do not have a lot of assumption checks for ANOVA and also ANCOVA. So in the but I think you know how to check some of the assumptions based on the what we learned. And if you have any questions like how to check the assumptions for an ANCOVA using R, you can let me know. But I just gonna warn you that it's not in the code, so just keep that in mind. Okay, so let's just get a review for the assumptions for ANOVA. So in ANOVA, all the observations are independently sampled, and within each treatment group J, the distribution of errors Eij is assumed normal. So normality of the residuals, right, in each group. And the homogeneity of error variance across groups. So this is homogeneity of variance. And the independence of errors, okay, independent error assumption. So you can see that pretty much it's like similar to the regression assumptions, right? And for the assumption for ANCOVA, we have two more. So besides all the assumptions for ANOVA, we have a homogeneity of regression slopes. So there will be no interaction between factors and covariates. So this we will examine this assumption first. So this is very important. This is gonna be our first step to before we conduct the ANOVA. Before we are conducting the ANCOVA. So in order to do that, in R, we don't have to specify, or we don't have to create two variables like T1 or T2. But first, I will introduce how to create, how to include the T1 and T2, and then we can move on to like the function that without the T1 and T2, because R is much more powerful, so we don't have to specify the T1, T2, like something like that. Okay, so but we can check that later. Okay, so the last one is the linear relationship between the outcome and the covariates. So I think you know how to do that, right? Linear relationship. So just check out the scatter plot. So pretty much for all the assumptions here, the only thing we are going to check in this lab, in the lab code, is just the homogeneity of regression slopes. So no interaction between factor and covariates. Okay, so that's the only one. So let's move on. Okay, so here we can see that as we mentioned before, the first step is to check if the interaction is significant, right? So we don't want that interaction is significant. So in order to create the interaction term, here is how we create the interaction term. We just use the C to time the two treatment variables that created. So for T1 and T2 here, those are two dummy coded variables. You can see that in the data set. Okay. So basically, the T1 and T2 is includes all the includes the information of the grouping variable, right? So it's a grouping information, and you can see in the full model, those interaction terms are specified, and in the reduced is we don't see the interaction term. Okay, so the first step is we're going to use the model comparison between the full model and the reduced model, which are these are two nested models, right? And then we're going to see if the interaction terms are significant or not. This is the first step. The second step is that if this interaction term is not significant, we can just use the reduced model as our full model in the second step, right? So as you can see here, in the second step, we're going to test whether the covariate is significant, okay? We want the covariate to be significant here. So, you can see the full model is with this covariate, and the reduced model is without the covariate, okay? So if our covariate is significant, we need to include that covariate into our model. If this covariate is not significant, we can just simply drop it, right? Because that covariate just does not make much sense because it's not significant. So this is very simple, right? The model comparison. For the third step, you can see that in the full model, we are still using this the full model in step 2, but the reduced model is changed. The reduced model is that we are missing the two treatment effect here. So that's the model comparison of the treatment effect. So we're going to see whether the treatment effect is significant or not significant. Okay, so let's run our R code. So first, you need to install some of the packages here, and then just call all the packages, and you can load our data set. Okay. Okay. So for the first step, we need to test whether the interaction is significant. So you can see here we specify the full model in this way. So C times T1 and C times T2, those two are interaction terms, right? So, and in the reduced model, even if the covariates are non-significant, we should keep them for theoretical. Yes, yes, I think so. Yeah, you I think you could just leave the covariates in your model because in the theoretic in your theory those are supposed to be the covariates there, so there's no harm to include that into the model. But from the model comparison perspective, like first is that you test the for the interaction first. So the covariate does not interact with the predictors here, and the covariate itself is not significant. So it might not help you much for your model, like for the model, but I think for the parameter estimates, it will be more accurate. That's what I think. So I think you could you can just still leave the covariates in your model, but it will not contribute much. Yeah. Okay. So first, let's see if our interaction term is significant. So just keep in mind that the first model in the ANCOVA function is the reduced model, and then we put the full model. Well, actually, you can just change that order, but you can see that maybe the f value will be negative. We don't want to see like negative f value, right? So, but the significance will be the same. So, not negative f value. I think it's the negative sum of square. So we don't want to see that. So so that's why we first put the reduced model and then we put the full model. Okay. Okay, so as you can see here, we don't have an insignificant interaction, which means that we are good. And for the second part, we are going to see if our covariate itself is significant, right? So you can see the full model is with our covariate, and the reduced model is without. Okay, so let's run that. And you can see here, well, if you type in options digits equals 2, and we rerun this. Wait, I think I need to type that first. Well, this is totally optional, so don't worry about that. I forgot the code. Let me see. Let's just use round if it's digits. I think it's not digits, right? It's a scientific something. But anyway, we just want to turn off the scientific notation, which is not very useful here, because apparently this is a very small p-value. So that, which means that our covariance is significant, right? So in this case, we need to include this covariance into our model. And for the third step, you can see that in the reduced model, we don't have the treatment effect here, the T1, T2. And if we run that, you can see that is significant. So therefore, we have a significant treatment effect. That's how we end up here so far. However, we don't have a further information anymore because we didn't do the pairwise comparison yet, and it will be a little bit time consuming, or it will be like kind of troublesome if you just create those two variables, right? In our data set, the variables are already created, as you can see here, T1 and T2. You could create those dummy variables, or like effect coding variables, based on the group information. But actually, what you can do is just to change the coding scheme itself instead of just create new variables. So in that case, so you can see the question here: how to conduct ANCOVA without creating dummy variables or effect coded variables, right? So in this case, we are only going to just use this group variable in our data set, and since our group variable is a factor, which means that it's an ordinal variable, or it's a categorical variable. So we need to recode that as a factor here, and that's how we do that here. Okay, so just give me 1 second. Okay, so this is how you get the factors, the variables into the factors. The next is that let me open the okay, so before we get into the using R to conduct the ANCOVA by another way, we already know the parameter estimates based on our T1, T2, that model, which is our model called the mod dot treat. Okay, so if you run that, you can see that the coefficients are stated here. So our T1 and T2 and our C, those are the parameter estimates, the coefficient estimates. Okay, so we already finished the model with the T1, T2 included. And the next, we just move on to just using this group variable in our model. So as you can see here, we make that into the factor already, and then this is the group mean. Okay, so this is the group mean. You can see that here. So these are the means calculated by group. So you can see each group mean. Be careful that those means are unadjusted. So we will use our code here to see the adjusted the means, which is the estimated marginal means later on. But this is just a descriptive for reference. Okay. Okay. So before we get into the using the group variable in ANCOVA, we need to change our contrast. So this is something is totally optional, but in order to be consistent with the result in SPSS, so that's how we get the result same as the SPSS. So that's how we do that. So in SPSS, the code is using the Helmert code contrast, which I just found out today. I tried a lot of times, and I found out that the SPSS is actually using this. So, so for this one, it's just to get the overall ANOVA table for the overall ANOVA table for our model. So this is how you change that contrast. Okay, so however, for the parameter estimates, we are still going to use the dummy coded variable, which is the we have the reference group as the group 3. Okay, so this is something is very important for you to understand. So in our overall, I'll repeat. So in our overall app table, we're going to just use this contrast coding, which you can see here. Okay, so this is how we specify the contrast for the two contrasts here. Okay, so but for the parameter estimate, our contrast is the same, right? So this is how we specify the contrast for our parameter estimate. Okay, so this is something you need to pay attention. And same as before, the first step is to test whether interaction is significant. In this case, we're just going to use C times the group. Okay, and in our reduced model, we don't have that interaction. So in this case, you can see that the result is the same. And then the covariates. So the second step, our covariates is significant. We're just going to use the group inside of our model. Okay. And then this is something a little bit different. So in our ANOVA table, we are not going to use this lowercase ANOVA. We are going to use a ANOVA function in the car package. So by using this, and we'll specify our type into type 3, and then our ANOVA table will look exactly the same as the in the SPSS. Okay, actually I just changed that contrast to something different, so I just gonna change that back and rerun this. Let me see. Yes. Okay. So that is our ANOVA table. Next, we need to get our parameter estimates. So we change back to the dummy coded contrast, and then we run this model, and then we will get our parameter estimate same as we get it before. Okay. So this is the parameter estimate part. Next, we need to get the adjusted means of y for each group, which is the estimated marginal means, and we use the EM means, and the model is the parameter estimate model, and then we specify here as we need to see the group. Okay, so the y for each group, you can see here. And the next, the final part is that we need to find out which group contributes to the significance here, right? So we need to do the post-hoc multiple comparisons. So here you cannot use the pairwise t-test function. You need to use this function, which is general linear hypothesis testing, which is a GLHT, because this adjusts for they have adjustments like 2-key and something else. So in this case, we'll just use 2-key here, which is a little bit different from SPSS. Well, in SPSS, you could choose that, but here we're just going to use 2-key. And if you run that, you can see here, this is our pairwise comparison result. Actually, we get like negative estimates, but you know it's positive and negative. It's just a direction, right? So this is a group 2 minus group 2 versus group 1. So if it's group 1 versus group 2, this will be positive, right? It's and the t-value is the same. So now we get the our the pairwise comparison. And if we go back to the slides, actually we already talked about everything before. So our conclusion here is that the intervention with a new curriculum is larger than intervention with a new technology, and the intervention with the new curriculum is larger than the no intervention, and the intervention with new technology is larger than the no intervention. So here, this is our conclusion based on our pairwise comparison result. Okay, so basically speaking, you don't have to create T1, T2. However, you need to use the coding scheme. You need to familiarize with the coding scheme here. Well, there's one question. Well, there's one possible question that if you just use this contrast, like the default contrast in R, like you don't like if you don't write this one, the contrast and you know contrast treatment or the contrast Helmer, actually that doesn't affect much. It just affects your interpretation of the parameter estimates, which is included in lab 5. Well, actually, I could open the lab 5 here. If you see that here. Okay, so the main idea is that you can still use the default coding scheme in R and getting that result. And but in that case, I think the default is that the first group will be the reference group. So in that case, you need to interpret it in a different way. Here, if you want to specify your own reference group, like in this case, it's group 3. you need to use this code to specify your group, your reference group, which here base equals 3 uh, is our reference group. Also, actually, also if your reference group is the last level, you can just use the contrast SAS, because in SAS the reference group is always the last one, so you can just specify like that one. Okay, so the result will be identical to this code here. Okay, so that's the coding scheme. And if we get a little bit review for the lab 5, you can see here, this is how you create the dummy coding, and also the interpretation of the dummy coding, the parameter estimate, the beta heads here. Okay, so this is something you need to familiarize with. And this is the unweighted effect coding. So you can see here, for example, the B1, the B1 hat. So this means the difference of y between the Q1. Q1 is the group 1, sorry, the group 1 and the grand mean. Okay, so everything is compared with the grand mean instead of the reference group in dummy coding. This is something different. Okay, so keep that in mind. And you can also check the Helmert one. So the Helmert one, I think, is something different. Let me see the Helmert coding scheme. You don't have to interpret that, but here, for example, the first one is just compare the first group and the second group, and the second one is compare the third group with the mean of the first group and the second group. So you can see that is something different here, right? So the negative one versus 1, and the negative 1 versus 2. So that's something you can specify as well. Okay, so I think that's it for today's ANCOVA. And if you have any questions for today's lab, or if you have any questions for anything else, just let me know. If not, I will just end today's lab. And I hope everyone is safe, and just take care. I'm still in New York City, and I hope everything will be better soon. Okay, so thank you. Okay, so see you guys, I think next week, right? Okay, bye guys.